Hi, welcome. Welcome to the YOL's webinar focused on the automotive industry. I think we have a lot of people already chimed in, and thanks for registering. And this we call this as a part one of China's pivotal role in automotive innovation. We got the some slide presentation followed by live Q&A with two analysts from y'all. Further ado, I think we should get started. Okay, one thing that I need to remind everybody, this webinar is linked to the white paper that y'all group issued last month. And we've got the QR code on the screen. Make sure to download the white paper. This explains a lot of things we'll cover today, but go down deep into the entire supply chain of the automotive industry. Especially, this is really the real strength of your group is they've got a global view. And I want you to take aside from this webinar, I would like you to download the white paper. Thanks. All right, so let me first introduce myself. My name is Junko Yoshida. I'm the longtime former editor-in-chief of EE Times. And right now, I am an independent journalist. I have my own writing going on every month on Substack. It's called Junko's Tech Probe. Now, I've been working with Yole for many years, but starting from this year, we actually further strengthened our relationship on collaboration. And Yole and I usually pick hot topics every month to go down deep into the what's going on in the semiconductor industry's technology innovations and market development. So watch out for the monthly BA at your site every month. All right. So I am going to introduce one of our first guests. His name is Pierrick Boulay. He's a principal analyst at he's responsible for automotive semiconductors at Yole. I've known Pierrick for a long time. I call him Mr. Lighter because he has been really the spearheading that what people need to know about lighting, VCSEL, automotive industry in general, but really focus on the sensors that go into the new generation of automotives. So, Pierrick, floor is yours. Let's get started.
Yes, thank you, Junko, for the introduction. So I will continue on the slides I pick up from the white paper. So I picked up a few topics from the white paper, and the first one is really to show our analysis regarding the semiconductor strategy from OEMs. And you know that semiconductors are now crucial for OEMs, but each of them has a different strategies. In the past, the global car market was really dominated by automakers from Europe, US, Japan, or Korea, because they were leveraging their expertise on internal combustion engines. But with the transition toward electric vehicles, it has completely reshaped the competitive landscape, and decades of know-how in ICE does not give any advantage in the EV area. So we analyzed some OEMs, and we witnessed different strategies regarding semiconductors. And we can split it into three different categories. So the first one are comprehensive OEMs that have a large coverage of semiconductor technology. So they are covering semiconductors related to power electronics, SoCs, MCUs, and so on. And they also have a deep expertise in semiconductors. So they are not only partnering with semiconductor companies or designing semiconductors, but some of them are vertically integrated. They are also producing their own semiconductors. So typically, these are the OEMs that are on top of this graph. Typically, Toyota or BYD are a good example of this type of comprehensive OEMs. The second category are selective OEMs. They have a deep expertise, but only in a selected semiconductors. They are in the, let's say, the mid part of this chart. A good example of that is Tesla, that is going down to the design of their FSD chip. So they are good in this type of chip, but they are not covering as much technologies as BYD or Toyota is doing. And the last part are progressive OEM. They are mostly focused on one type of semiconductors. Most of the time, it's related to power application because it's related to the transition to electric vehicles. And they are most of the time establishing new partnership with semiconductor players. So it's kind of new in the automotive industry. So OEMs are having a deeper view on the semiconductors and are making new partnership or direct partnership with semiconductor companies to negotiate the price directly with semiconductors, and then tell the tier one to use one semiconductors or other at a fixed price. When we look at this graph, we see that most of the Chinese OEMs have a large coverage of semiconductor technology, and it is giving them a very strong advantage compared to global OEMs. They can move faster in the development of their car. And then when moving deeper to the Chinese market, we see that China has a dominant position in the EV supply chain. So from raw material to produce magnets to battery technology or high volume battery manufacturing, we see that the OEMs are now going deeper in the supply chain. They are moving to making their own SoC or MCUs. There are also many new players in the ecosystem. So most of the OEMs in China are new. So nice examples are Li Auto, NIO, XPeng, or BYD. And all of them are moving deeper in the supply chain. When we look as well on the supply chain and especially in tier one and tier two, we see that many tier one have emerged, resulting in fierce competition in different categories, so related to battery, inverter, DC-DC, and so on. And this is leading to a strong cost reduction. And same for tier twos or semiconductor supplier. There are more and more players, and that allows them to move faster in the ecosystem. And in China, there is some kind of policy, and the government is currently encouraging to produce car with local suppliers to achieve a supply chain independence. And the current goal that is fixed by the government is to have 25% of semiconductors supplied by local players in 2025. This goal is expected to increase in the coming years, and I think we will discuss more in the discussion later on. And as this goal is to establish self-sufficiency, the latest Shanghai Auto Show was a good example of that, with more more and more players involved in semiconductors that were present in this auto show. And it was also interesting to see that one tier one showed a powertrain controller made with 100% of Chinese parts. So that's a big change compared to previous development where we still saw that some parts were supplied by global players like TI, Infineon, XP. But this one was really particular as it was only supplied by Chinese suppliers. To continue with the electric vehicles, I wanted to talk about the silicon carbide and the 800 volt architecture. So SiC provides a clear added value for the vehicle user. So, for example, it is giving longer driving range thanks to lower power and efficiency losses in the traction inverters compared to the classic silicon-based IGBT inverters. And until recently, SiC was almost exclusively used in the full electric vehicles, so somehow limiting its adoption. But also the SiC adoption is limited in a hybrid vehicle. It is increasing very fast in plug-in hybrid vehicles because they are using high capacity batteries. And that's a good place to use SiC-based components. So SiC devices can be found in all systems in the car, so into the DC-DC converter, the OBC, and so the inverter, and so on. But also in the DC charger that is quite important to the user. And this is used in combination with the 800 volt architecture that enables a faster charging and somehow solving the range anxiety that is a key question for any buyer of electric vehicles. And the combination of SiC and 800 volt architecture was a perfect match, but somehow limited at first to premium vehicles. But now the combination with 400 volt architecture is offering a first step for OEMs to make this transition from silicon to SiC. And I think that's somehow this is what we will talk about during the discussion. Next topic will be related to ADAS, and I wanted to touch base on the driving evolution. So from level 1, that is belong to the fit-off application, to level 2, belonging to hands-off, and level 3, 4, and 5, belonging to the eyes-off application. So each of these applications, so in each of these levels, are using different number of sensors. So you have here below the different types of sensor. I make the difference between sensors for ADAS, so typically the camera, the radar, and the LiDAR, and the sensors that are used only for parking applications, so viewing camera and ultrasonic. So basically, when moving from a basic fit-off application, there is only need to have 2 sensors, so one forward ADAS camera and one radar. And then moving to level 2 application, the number of sensor is increasing. So in average, between 1 and 3 cameras and up to 3 radars. So basically one long range radar and 2 corner radar. So it's more sensors, but it's also new generation of sensors. So for example, camera having higher resolution, higher dynamic range, and so on. Same for the radar. But it's also new computing generation. So for example, moving from the Mobileye IQ2 to IQ3 is also a way to process more data and increase the computing power. When we look at level 2, so hands-off application, this is quite large. So going from simpler application like the traffic jam assist application to more complex applications belonging to what some people call L2++ applications, like the navigate on autopilot feature. That was, let's say, enabled by Tesla some years ago, but now really popular in China. And we see a very different behavior because the Chinese OEMs are implementing a lot of sensors, so much more than global OEMs. So they are even using LiDAR for the NOA application. And it is quite important because they have to monitor not only the vehicles or the traffic in the streets, but also pedestrian and the cyclist. And LiDAR is crucial because they have is used to monitor the behavior of this pedestrian and bicycles because they are somehow unpredictable, and this is very useful for this NOA application. And then moving to a higher level of automation, the number of sensors keeps increasing. We expect that more than 20 sensors will be used for ADAS, maybe even more. All the cameras around the car will have ADAS functionality, so there will be no distinction between camera for ADAS and camera for parking. All the camera will have ADAS functionalities. Number of radar will be increasing, so not only for front and rear, but maybe for the side as well. And more LiDAR to have coverage around the car, not only on the front, but also on the side as well. What is the difference between hands-off and eyes-off application is that the driver is responsible in any case in hands-off application. So driver of Tesla or using the NOA application in China, they are always responsible in any case. While in the eyes-off application, the OEM will be responsible under automated driving. So that's why they are implementing more sensors and more redundancy in safety critical systems. And then when moving to level 3 regulation, some countries over the world, for example, in Germany, or some states in the US have already allowed such regulation. Most of the time, the use case is to have highway driving, and the ODD is quite limited. China is also introducing such regulation, but it's quite strict. And there were new guidelines that were published by the Ministry of Industry and Information Technology. So some of them are related to ban the use of pioneer user like beta testing programs. I will not go deep into each guideline, but some are quite important. So automakers need to avoid some terms like automatic driving or autonomous driving that could be misleading. It's quite similar to what Tesla made in the past, and I think that in China they want to avoid the issue that were faced by Tesla in the US. And also something that is very important, driver monitoring system will be mandatory and cannot be disabled during the driving task. And these regulations are coming shortly after some accidents that occurred recently with 3 fatalities. It was involving a car from Xiaomi, and the Chinese government, they want to avoid too many accidents like this in the future. To continue on the ADAS and safety, we clearly saw that Chinese OEMs were implementing innovation at a fast pace, so not only at the sensor or on the electrification space, they are also introducing innovation for ADAS and for EE architecture that will be that will change or that will need to change to enable more complex application. So moving from a distributed architecture to a more centralized architecture um, with the processing that will be gathered in a domain controller. So the processing will no longer be in the camera or on the radar or on the LiDAR, but will be gathered inside a single domain controller. This is what have done several Chinese OEM. One is going even deeper in the centralization, so mixing ADAS and infotainment in the single box, where ADAS and infotainment are gathered in two PCBs, but in a single box. Last but not least, so working with China, we see two directions working with China. So the first one is in China for China, where we see global OEMs partnering with local players. So we see here two examples. So one with Volkswagen, for example. So making joint venture with Horizon Robotics to accelerate the ADAS development for the local market, or with XPeng as well to develop a platform and a new car for the Chinese market. And same between Toyota and BYD to sell vehicles only in China. The second direction is to leverage China's EV strengths to accelerate the development and sell cars in the rest of the world. That is the case of Stellantis, for example, partnering with Leapmotor to sell Leapmotor's EV through its network in Europe. It's also a way for Stellantis to learn and enable a faster development of EVs. Stellantis is already selling EVs, but they are built on a multi-energy platform. That means that they are not optimized for EV. And global OEMs will learn from the Chinese and try to catch up to sell EV cars that are optimized for the electrification. There are other examples related to semiconductor players like Infineon or STMicro buying 6 substrates from China directly to cut costs and speed up their product development. So this is the end of this presentation. If you want to have more coverage, you can go into these reports. Some were updated in 2025. Some will be as well in 2025. It's quite easy to find more information in these reports. And so back to you, Junko, for the discussion.
Thank you very much, Pierrick. That was quite interesting. And I actually would like to open the floor so that I actually see one question on the chat box. Everybody on this call, please use the Q&A chat box at the bottom of your screen and send in your questions. As we go along, we'll answer some of the questions. And before we get to that, let me ask a couple of my burning questions first to both Pierrick and you. Let me first introduce, joining this Q&A is Yu Yang, and he is a PhD and principal analyst, automotive semiconductors at Yole Group. I call him my secret weapon if I want to know anything about Chinese automotive industry. So he will be our guide, not only to the EV architecture, but also the Chinese semiconductor market trend in general. Hi, you. How are you?
Hi, Jinko.
Thanks for joining. All right. Now let me ask the first question really to both of you is, we hear a lot of stories about China. I think Pierrick also mentioned that China is going down deep in supply chain, meaning that Chinese OEMs are not just satisfied making cars, but they're also developing their own semiconductors internally. So can you walk me through that some of the names of those Chinese OEMs who are already internally developing their own chips? And what kind of chips are we talking about here?
Yeah, so there is a very strong trend in China to develop their own semiconductors. In the discussion, in the presentation, I mentioned BYD, for example. They have a large coverage of semiconductors. They are involved in many types of semiconductors. So from let's say semiconductors related to power electronics, but also related to MCU, SoCs. They are pretty large and they are vertically integrated.
Yeah.
I also mentioned Toyota, but we also hear more and more smaller OEMs like Xpeng, for example, developing their own SoC.
Wow.
Most of the time, it's for ADAS application,
Mhm.
and they want to have a better control of the supply chain and as well implement their innovation and be independent to global suppliers. Maybe Hugh, you can complete.
It's quite interesting because semiconductor it's always a focus in China. I mean, much more emphasized compared to the rest of the world. And from kind of our analysis, we see there are a few things which is getting more resources from the OEMs. One is power electronics. I think also Perica already mentioned that one. And the other one is the advanced SoC, which is used for both the ADAS functions and also the smart cockpit functions. I mean, these two makes perfect sense because if you know that it's kind of the new trend of the whole industry is moving to electrification and also to more intelligent functions, which is based on power electronics and also the advanced SoC. So that's why I mean I call them kind of new semiconductors because those kind of things doesn't exist. I mean in the previous generation of automotive. So it's kind of new things and there's not really a well-established supply chain yet. So that's why I think it's a lot of Chinese OEM they are stepping up. And another thing, actually, we also see a lot of investment is MCU, which is a quite conventional one. That's pretty interesting. But also, I think there's a kind of rationale behind it, because even though MCU has been widely used for cars for decades, but on the other side, we are also seeing the evolution of EE architecture, and which needs actually a new family of MCUs for the domain controller, for the zone controllers. So that's create kind of a new need. And also, I mean, in the chip shortage period, we also see that MCU is the most needed one. So I think that's also kind of triggered a new investment. But this is not only in China, to be honest. This is a global kind of phenomenon, I would say. So to make a summary is that power and advanced SoC and also the MCU is kind of the most invested kind of semiconductors among OEMs.
Can I follow up on that? When you say new generations of MCUs, are these based on like traditional ARM or are they based on RISC-V? What are you seeing?
There's no really distinguish. I mean, between if it's ARM based or it's a power PC based or I mean, it's kind of everything you can still use, but but we do really see. I mean, ARM is still the most popular core. I mean, worldwide, especially for the automotive part. But on the other side is that because of the increasing awareness of kind of self-efficiency or independence, so we do see a quite increased interest in China on the RISC-V based MCUs, and also I mean along with the other even self kind of side architectures are also emerging there. I mean, I can give you a lot of examples there, but I mean, we cannot go to the detail today. But it's not really which type of specific architecture is more preferred. It's kind of they prefer to have least independence on MCU in general, and then it's up to the situation of each of the OEMs or the tier 1 or tier 2s. They choose up which kind of architecture they will go.
Yeah. All right. Now I'm seeing a lot of questions from the floor. So I think one of the things that a lot of people on this call are interested in is really the difference of sensor combinations used in China vehicles versus global OEMs vehicles. Can you address some of those things, Pirik? What are the differences, main differences?
Yeah. So what we see in China, so they are using the same type of sensors as global for basic ADAS functionality, so cameras and radars. But for the NOI application, they are also implementing LiDAR a lot. And what we see is that there will be two types of LiDAR. So what's the big difference between the Chinese market and the global market is that in China, there will be low-cost market for the LiDAR that will be around $200 or even less. For the NOA application, that will still be a level 2 application, so the driver will be responsible in any case. And the second market will be LiDAR made for level 3 application, so at a price around $500 or slightly less. That will be higher resolution, longer range, but will be specifically addressed for the level 3 applications. So longer range, higher resolution, better angular resolution, and so on. And that will be the difference between the two applications, between level 2 and level 3. And globally, when we look at level 2 plus cars in China, they are using a lot of sensors, much more than global OEMs. So it's not only the cameras, but also the radar. LiDAR, some are using up to 3 LiDAR on the car. So in total, we already saw some cars with around 15 sensors for ADAS, and they are still level 2 cars. So
15 sensors for level 2 cars?
Yeah.
Oh, wow.
So the goal is to have some fluent driving task and anticipate some behaviors that cannot be anticipated from the pedestrian or the cyclist. And for that, the OEMs, they want to implement more sensors on cars.
I think maybe I can also pick up from here is about it's still L2 in China. That is because of the legislation, because legally there's no L3 possible in China for the moment yet. So I think also we mentioned it also in the presentation is that actually this year is kind of expected to have L3 legalized in China, and also actually we see multiple OEM they have announced their cars that is L3 capable. But for the moment, because there was a quite fatal accident happened right before the Shanghai Auto Show, so that's and the government put a very strong brake on the kind of the autonomous driving kind of the wording things, and also postponed the legislation of L3. So that's why for the moment it's still L2 is only L2 available. But on the other side, I have to say is that I mean, we identified this trend since last year already. We see that the focus of the industry is shifting from electrification to ADAS. I mean, last year in our report of the Beijing Auto Show, we already mentioned that one. And this year, I think it's getting more evident, especially if you see the announcement from BYD, from Geely, from Chang'an, all these volume players. They are kind of making the L2 plus functions with the mainstream of the fleet. And so that's the situation. And then I don't see any kind of slowing down or stop of the ADAS functions. So even though the government is very strict on using the word of autonomous, so instead you should really say assisted. But still, the development and also the investment to this domain, I think is just continuing. So that's not stopping.
All right, very good.
That's maybe just to highlight this. It's what we saw from publication from BYD or Li Auto. So putting more ADAS functionalities in all of their car models. I think you remember the BYD Godzai A, B, C to implement more and more sensors in all of their car models.
Right. Yeah, that's already happening. Now, there's a question from the floor that I think you are the one who mentioned the 25% semiconductor content per car in 2025. That is government kind of wish, right? And how much content do you see for 2030? What's your prediction?
That's also, I see it's really a lot of questions about this one. I think it's also our concerns, to be honest. I think actually you see in this white paper, this is the first part, and we really focus on the OEM strategies on that one, but we do see this kind of shifting floor of the industry. And that's why also I think we are now working on the second part of this white paper, which will be issued by September. But for the moment, we do have a lot of information already about it. I think maybe that's part of we can share a little bit. So the 25% kind of localization in China in this year. So it's kind of as you mentioned, it's a government wish. It's not a legislation or it's
Right.
nothing with compulsory, but it's kind of the strong push of the government. And for the information I get is that they think this has been achieved. And also, as Pierre pointed out, the government is also pushing to more ambitious goals in the next years. But there's no really official rules to say, okay, how this is going to happen. So that's kind of a lot of best practice is happening. And also, I mean, we are open to discuss with our client, or if you are interested, we can also have follow-ups. But in general, I would say is that also I see the question is that citing the report of Nikki and the goal of the government or next one, I think is clear that by in 2026 or 2027, I think no later than 2027, they want to see 100% Chinese chips in the car. I mean, it looks quite amazing, I would say. That's also our pickup for the Shanghai Auto Show. I really see in the past 12 to 18 months, there has been huge progress of the tier 2s in China. And I think the goal of 100% by 2026 and 2027 can also be achieved. But there is a very strong but. This is not saying that China is pushing Infineon or ST or TI out of the market, but they want to kind of have one or two, at least a demo to show that they have the capability to do the self-efficiency. So I think that's kind of the main information I would say.
Right. It's a difference between aspirational and mandatory. That's interesting.
Yeah.
And I think before we close, I think I'd like to mention something about, if we talk about China's EV, you cannot mentioning this all SiC BEV, battery EV with an 800-volt architecture. There's a slide on that, and I kind of got that piqued my interest because when you say all SiC, does that mean that we have not achieved the all SiC yet in most EVs in the West? Or tell me where we are today.
Yeah. That's also quite interesting. I mean, silicon carbide has been really the hot spot for the last years, and we are really seeing fast progress adoption in China. But normally, I mean, we always associate with the use of silicon carbide to the powertrain. I mean, actually starting from the inverters, we also see the applications with the OBC and the DC-DC. So that's kind of the common knowledge of using silicon carbide on the EV. But actually, it's not only BEV. We are also seeing the penetration to also plug-in hybrid, which is actually bring the most growth in the past years. But also, I mean, if you see the slides, actually it's going beyond just the power chip. And also you can use it also with the thermal management system, especially the air cool, because there's also a motor there. And you need to at least kind of power switch to turn to drive the motor. And that's also quite matters with the efficiency, which that's why we use silicon carbide. But from my perspective, and of course you can have some benefit of using silicon carbide at some cost. There's always cost associated to that part. But I think it's one of the motivations I see is that, of course, is efficiency. But second one is that silicon carbide is kind of have the image of high tech, advanced technologies with the consumers. So that's why some of the OEM they are kind of pushing out these OSIC kind of solutions. I mean, that's also shows that how the customers is accepting silicon carbide. And I also want to say is that this is also give a big thanks to the fast development of silicon carbide substrate in China, because of a lot of local suppliers, they have really lowered costs over the past years. And to be honest, we are expecting that one to continue in the next years. So that's also allows, I mean, the previously some applications which is too expensive to use SiC, but now it's possible, and including the DC charger actually. Yeah.
All right, very good. I think there are still a lot of questions not answered, but that we will make sure we got all your information. So our analysts will respond to each one of you that who laid out the questions here. But also you will receive an email from Yol for this webinar, and please use that email to if you have any further questions to Yol, please use that email to respond. Write down your questions for the company. All right. Well, we could go on forever, but I think we have to close. And thanks for listening, and thanks for the Pierrick and you. And not to worry, we will have the second part two of this Yo's automotive white paper coming, and we will have the part two of this automotive webinar on September 25th, I think. And so tune in and track us. And thanks for listening. And the playback of this video will become available next Monday. Thank you so much.